Example 6. God has promised to give you $1,000 5 years from today. Every year after that, He'll give you an amount that is 5% larger than the previous payment. God promises to make the annual payments forever. What is the value of the promise today using a discount rate of 6%? So the first step is to figure out what type of cash flow we're working with. So this is a growing perpetuity. Okay? So God is making a payment every single year, and it grows at a constant rate, and it goes on forever. So it's a growing perpetuity, and we're trying to calculate the present value as of time 0. What's the value of the promise today at a discount rate of 6%? Okay? So we're going to start by drawing the timeline. Timeline looks like this. Today is time 0, and the first payment occurs in 5 years, $1,000. And God will give you an amount that is 5% larger than the previous payment. So the second payment in year 6 will be 1,000 times 1.05, and year 7 you'll get 1,000 times 1.05 to the second power. And the pattern continues until forever. Okay? The discount rate is given, it's 6%, and the ultimate goal is to figure out the value of the promise today. So we're trying to calculate the present value of this promise. Okay? So again, the first step of any multiple cash flow problem is recognizing what type of cash flow pattern you're dealing with. Here we have a growing perpetuity. And since we're trying to calculate the present value of a growing perpetuity, the only logical formula that we can choose is the PVGP formula, present value of a growing perpetuity formula. And it looks like this. So, as with all the other annuity and perpetuity formulas, we always check when the first cash flow of the pattern occurs. In this case, the first cash flow occurs in year 5. Okay? And this T and T plus 1 pattern shows you that if the first cash flow occurs in year 5, the value that we get using this formula will be expressed in time 4 dollars. Okay? So I'll just indicate that on the timeline. So whatever value that we get, it'll be expressed in time 4 dollars, which means there's going to be an additional step. Once you get this PVGP4, you're going to discount this back to time 0. Okay, that's the second step. So we'll plug the numbers in. PVGP as of year 4 is the cash flow that occurs in year 5. That's the first cash flow, $1,000 over R minus G. R is 6%. G is the rate at which the cash flows grow. Okay, it grows at 5% per year, so it's 5%. Just write G, 5%. And this value is $100,000. Okay, we're not done, right? This value, as we stated up here, is expressed in time 4 dollars. We're trying to calculate the PV as of time 0. We wanted it in time $0, so it involves a second step. So we're trying to focus on this part right here. Okay. So the second step is we want to convert this $100,000 back into time $0, and we're going to use the PV formula to do that, which is just PV equals future value divided by 1 plus R to the nth power. Here, the future value is this. It's in year 4. Okay, so we're going to use that as the future value. 100,000 divided by R is still 6%, so 1.06 raised to the 4th power. Okay, so we're going from time 4 to time 0. So 4 discounting periods. And the number that you get is this. So this is expressed in time $0. Exactly what we're solving for. Okay.